Hello everyone, today we are going to talk about problems related with containers. First, we'll see the types of container. There are basically three types of container. These are closed container, open container and connected containers. So, we'll discuss each of these one by one. In this video, we'll talk only about closed containers. In our next video, we'll discuss about open container, and in next video, we'll talk about connected containers. So in the category of closed containers, we have two more types. These are also very important. These are closed rigid containers and closed non-rigid containers. What's the difference between these two? We'll discuss them as well as we'll solve problem related to these. So stay tuned. So basically, talking about closed rigid containers and closed non-rigid containers. In case of closed rigid containers, we have moles and volume of the container to be constant. In case of closed non-rigid container, moles and pressure is kept constant, right? We'll see what are these examples. So example of closed rigid container is gas cylinder, and here it is thick skinned, so moles and volume are constant. In case of non-rigid containers, example are balloon, air bubble. So these are basically thin skinned, and here we have moles and pressure as constant. So we'll solve problems related to these. So let's discuss about closed rigid container in detail. Then we'll go to closed non-rigid container. So we have closed rigid container. In this case, we have moles and volume to be constant. As per ideal gas equation, we have PV is equal to nRT. We know R is constant, V and N are also constant as per closed rigid container. So pressure will be directly proportional to temperature. On increasing temperature, pressure also increases until explosion occurs. So Pi by Ti is equal to Pf by Tf. Initial pressure divided by initial temperature should be equal to final pressure divided by final temperature. We'll solve problems based on this. A gas cylinder contains a certain gas at a pressure of 12 atm at 27 degrees Celsius. Due to fire in room, the temperature starts increasing. If the cylinder can withstand a maximum pressure of 18 atmosphere, find temperature at which explosion will occur. So it's gas cylinder, which means it's closed rigid container. We have discussed the formula, which is Pi by Ti is equal to Pf by Tf. We'll simply apply this formula. In this case, moles and volume are constant here, so pressure will be directly proportional to temperature. This formula will be applied. So we can write here that initial pressure is 12 atm, initial temperature is 27 degrees Celsius, which is 300 Kelvin, right? If we add 273 to it, it will be 300 Kelvin. Final pressure is given 18 atmosphere. Final temperature at which explosion will occur, we have to find out. We'll simply put the value in Pi by Ti is equal to Pf by Tf. So 12 by 300 is equal to 18 by Tf. So we'll get the value of Tf. It will come out to be simply, this is 3, so it will be simply 450 Kelvin, right? So this will be our answer. Hope you understand this. Now we'll similarly talk about closed non-rigid container, and here it is thin skinned, example is balloon as well as air bubble. So here it's fragile in nature, which means it can be broken easily. The walls are fragile in nature, so moles and pressure are kept constant here. If we write ideal gas equation, PV is equal to nRT, we know R is constant, N and P are also constant here, so V will be directly proportional to temperature. So Vi by Ti is equal to Vf by Tf, right? Volume is directly proportional to temperature. In this case, Vi by Ti is equal to Vf by Tf. So we'll be using this formula to solve numericals related to closed non-rigid containers. Let's solve a problem. Here, one thing to note here is, on increasing temperature, volume also increases until maximum volume is attained. After this, the non-rigid container will burst, right? So let's solve a problem. A balloon is inflated to 4/5 of its maximum volume at 27 degrees Celsius. Find temperature at which balloon will burst. Balloon is a closed non-rigid container where we'll apply this formula which we discussed earlier. Moles and pressure both are constant in this case. So Vi by Ti is equal to Vf by Tf. Let's write these values. What is the value of Ti? It is 27 degrees Celsius, which can be written as 300 Kelvin. By adding 273 to it, we can write it as 300 Kelvin. Talking about initial volume, so it's inflated to 4/5 of maximum volume. So maximum volume is the final volume at which it will burst. So Vi is 4/5 of Vf, right? Now let's put these values. We'll get 4/5 of Vf divided by 300 is equal to Vf divided by Tf. On solving, we'll get the value of Tf. It will come out to be 75 multiplied by 5. It will be 375 Kelvin. So this will be our answer in this case. Hope you understand both of these problems.